To calculate our average atomic mass of an element, we need to know the number of isotopes, their masses, and their relative abundance. Sometimes they'll give us unknown elements, and then from that we've got to determine what that element is. So we're going to look at it that way without knowing what the element is and being able to look on the periodic table and kind of cheat ourselves. But when we are doing ones that we already know, we can look on the periodic table and check that we did our math correctly. It should be relatively close. So there is a question where it says there's element X, and I'm going to give a shorthand notation for that. There's going to be element X, that's 10, and there's going to be element X, that's 11. And element X's mass, true mass, is 10.012, and it has a relative abundance of 19.91%. And element X11 has a mass of 11.009, and it has a relative abundance of 80.09%. Alright, so what they were basically telling us in our notes, or what I was trying to explain, is that we need to take the masses of each. So we'll take the mass of the first one. We're going to multiply it by its natural abundance, but we need to take it out of a percent. To take both of these out of a percent, we can just divide by 100, or we can just move our decimal 2 places to the left. So I'm going to go ahead and do that so I know this is really what it is, and I can get rid of my percent sign. Alright, so I take my first one, so it's 10.012 times 1991 point, I'm sorry, I forgot my decimal. Then I'm going to add that to the product of 11,009. I'm going to multiply that by my 0.8009. Okay? So I need to multiply what I have inside my parentheses first, then I'm going to add everything together. Okay, so when I multiply my 10.012 times 0.991, I get 1.993, and that's where I'm going to stop, because if I look at my sig figs, I have 5 sig figs in my first number, and I have 4 sig figs in my next number. So I'm going to stop right there because I have 4 sig figs. And I'm going to add that to whatever I get when I do 11.009 times 10 times 0.8009, and I got 8.817. Same thing. I'm going to stop right there based off of my sig figs. I have 5 sig figs, and then I have 4 sig figs. And now I can add those two together. When I add those two together, I get 10.881. Then I can look in my periodic table and figure out, oh, what is this mystery element that I have just found my mass for? And it looks like it is boron. And if I look at the periodic table, it is indeed boron, because the mass of it is 10.81. Okay? So even during this, we need to make sure we pay attention to our sig figs. You really shouldn't have a whole bunch of digits. It should be relatively concise. If you look on your periodic table, some of your masses will have more digits than others. There's really no more than 5. That's kind of the max for most of these, and some of them are even in parentheses because those are still kind of estimated because they're newer elements. All right. If you have questions of how to calculate this, please let me know, and I will be sure to help you or go over this again with you.